Hey guys, I'm Molly. I had problems 231 and 232, and so I went ahead and modified 31. So the problem was we had our diagram here of a couple pulleys, B and C, with blocks D and E hanging onto those pulleys, and then we had a point at A and then a force coming down from that. So the problem was blocks D and E have a mass of 8 kilograms and 10 kilograms respectively, and X is equal to 5 meters. And our goal is to determine the force F and the sag S for equilibrium. So our givens are mass of block D is 8 kilograms, mass of block E is 10 kilograms, X is equal to 5 meters, gravity is 9.81 meters per second squared, and then we need to find F and S along with angles alpha and beta to solve this problem. So our first step is to calculate the weight of blocks D and E, which is just mass times gravity. So for the weight of D, we got 78.48 newtons, and the weight of E, we got 10 times 9.81, which is 98.1 newtons. And we know that because there are no outside forces, tension is equal to the weight. So that means that the tension of D and E is the same as the weight. Solve for S is the next step in the problem. Sorry. So we need to take the sum of the forces in the x direction and make sure that that equals 0. So we end up with negative tension D times cosine alpha plus tension E times cosine beta. And then we can just set those equal to each other. And then we're going to solve for, we need to kind of put these in their own form. So we know that cosine alpha and beta, based on this diagram here that is not in the next slide, we can just use our trig. And so we can say that cosine alpha is equal to 8 over AB, and AB is, using the Pythagorean theorem, s squared plus 8 squared, with a square root over that. So we know that cosine alpha is 8 over square root s squared plus 8 squared, and then just the same thing with beta. Sorry. Just the same thing with beta. Same areas of equations. So this is, again, still solving for S. So we have taken, my bad. I guess I did copy all of these over here, just so we had everything together. But so we did all that and got our cosine beta, cosine alpha, and then we can sub our new values for cosine alpha and cosine beta back into our sum of f of x. So then we get tension of D times our 8 over square root s squared plus 8 squared equals tension E times 5 over square root s squared plus 5 squared. And then we know tension of D and E, which was just our weight, so we can solve for S. So we just put in the 78.8 for tension D, 98.1 for tension E, and then we just isolated S, got S by itself. So we ended up with S is equal to 6.01 meters. So that's the first part of our problem. And then we need to solve for alpha and beta to be able to get our force. So now that we know S, we can just sub that back into our cosine alpha and cosine beta equations. So for that, we have the inverse cosine of 8 over 10.006, which ends up with 36.91 degrees. And then for cosine beta, we have inverse cosine of 5 over 7.818, and that leaves us with 50.24 degrees. And then our last step is just solving for force F. So we just need to sum up all the forces in the y direction. So that is tension of D times sine of alpha plus tension E times sine of beta minus F is equal to 0, so we can just move F to the other side and solve for F. So if we plug all of our tensions and angles in there, we get F is equal to 47.1319 plus 75.4124. And then just adding those together, we get F is equal to 122.5 newtons. And we have solved our problem. Thanks for watching.